Welcome to Trending in Education. This is Mike Palmer. Today, we're going to go into some depth on a subject that I always enjoy getting into, talking about architecture and how structural thinking relates to learning. To do so, I'm joined today by Marcio Sequeira, who is the founder and CEO of a company called MOLA, which is doing just that, bringing structural thinking and learning about architecture out into the world. Marcio, welcome to Trending in Education.
Thank you very much for having me. It's a pleasure to talk a little bit about our work and what we've been doing with these physical models to teach structures to anyone interested about the buildings and the things around us.
Absolutely. There's an awakening that can happen in folks when they start to think like an architect, think structurally. And I know that you have an interesting backstory to kind of set us up here. We always start there with your origin story. So can you catch our listeners up a little bit on who you are and how you got to this point in your career?
Okay, I'm from Brazil and I'm an architect. And since I was a kid, I was interested about architecture and structures because my father works in the industry of steel construction. And my mom is graduated in physics. And I don't think it's a coincidence that I'm working with a physical model that simulates structures to teach
Yeah.
physical phenomena.
Mhm.
So I think it's all related to my education, my background, I think.
Yeah.
And during my studies as an architect, I was struggling about structural classes. And usually in the university, those subjects are taught mainly through calculation. So it's
Mhm.
a really abstract subject. And I like math. I used to do all the calculations during the tests and during the classes, but at the end, I couldn't use these as good information to designing a building, for example. And
Right.
so that's how I started to think about something that could make me visualize and understand in an intuitive way how structures and how buildings behave. So this
Yeah.
was how I started thinking about creating something.
Yeah. Well, and as a parent of a 5-year-old, that immediately brings me to Legos and magnetiles and some of the products that are out here in the US where, like if you look at how we start as humans, we're very structural thinking. Blocks have been around for years. We're always thinking about that when we're young, but then something changes. And later on into our K-12 education here in the US, there's little or no structural thinking, architectural thinking, design thinking in there. What's been your perception of how formal or informal education helps us develop new architects? Because from my perspective, it seems like there's a real natural affinity to this stuff, but somewhere along the line, really in K-12, we kind of stopped teaching it. How do you think about developing that architectural eye, that mindset, structural thinking? How do you think about all that?
Okay, I think architecture is something, it's a really difficult task. We are talking about a lot of different professionals working for the same thing, which is a building, which is
Mhm.
something in space. So to have this notion about space and three-dimensional things and how this will feel inside or outside of a building, how this relates with the surrounding. So there's so many complex aspects through architecture. And
Yeah.
basically more specific about structures that what we do. These global and 3D visualization is something so important to understand how buildings and structures behave. I
Yeah.
think having physical models is something really important to have to
Mhm.
develop this intuition about real things. And
Mhm.
I think in education, there's a lack of this type of approach,
Yeah.
especially when we get older and things are more theoretical behavior, how we teach things. And
Mhm.
even in graduation, I think we need to use more visual and tactile experience so we can relate with to the space in how these things behave. So
Mm,
this was one of the things that stimulated me to create MOLA during as an architect student. It's having these hands-on activities in class. This always
yeah,
got my attention, my interested about learning visually. I think everyone thinks
yeah,
different, and some people are more to the technical stuff, and people that like better to use models and to see things. And I think we need more ways of teaching the same thing.
yeah, absolutely. It's interesting. I think I mentioned to you as we were setting up, you really can't get through an education podcast without talking about artificial intelligence, which I think we'll probably want to get into that a little bit later. But as you're talking, it immediately made me think about virtual reality and augmented reality, which is another place where you're seeing a lot more emerging technology to help us think spatially and even manipulate objects in virtual space, virtual reality. What you're doing with Molda, and we could probably get into it a little bit more, is more like a physical kit. But I'd like to get some of your perspective on some of the emerging technology around VR and AR and whether those technologies can actually help with some of the structural understanding of architecture that you're talking about.
Okay, I will go to some points here to make it clear for the listeners. And
Yeah.
when you say we're talking about MOLA, MOLA is a physical model, just like a Lego
Yeah.
for engineers and architects, that
Hmm.
we use springs and magnets to connect all the pieces. And
Hmm.
we are using springs to amplify the behavior that happens in a real building. Because
Hmm.
when you look to a building, it seems like everything is on its place and it doesn't move, it doesn't happen anything. But actually, the building is
Yeah.
moving sideways, it's get deformed, but we cannot see it. And with this
Yeah.
physical model, using the springs, we amplify these deformations. So people
I
can
see.
apply loads to those structures and see how they behave visually. So this is
Mhm.
how we try to teach people how buildings behave by a physical
Yeah.
experiment with this physical model.
Mhm.
So this is
Mhm.
how MOLA works. And one important thing to say is that MOLA doesn't replace any of the steps during a design of structure, buildings
Mm.
or bridges, and any other structure. MOLA is just a qualitative analysis that we make with this
Mm.
physical model that will
Yeah.
only add to the process. So we're not replacing any
Yeah.
of the other uh, steps that you need to make all the calculations to verify the structures to make this real size on the specific for safety, for comfort, for a lot
Right.
of aspects. So this is really important to make it clear that we are designing
Yeah.
to help people to understand better how things work. And
Right.
going to all the digital and all the tools that we have today and how the world is growing to this direction.
Right.
One
That's
thing that
CAD, right? People talk a lot about
yes,
like auto CAD as like some of the foundational elements of architecture nowadays are kind of software powered.
of course. And basically on structural engineering, we have so amazing tools for analyzing different structures, for optimizations, and a lot of things that computer can do so fast and so power that we have answers that we didn't have before, like maybe like hand calculation. This is really amazing. And but
Yeah.
at the same time, it's something that we need to take care when we are going to this direction, because I think we are losing some really basic knowledge through our education system. And especially when I talk about education, I'm more about architecture and structural engineering,
Yeah.
um, that we see a lack of information or intuitive behavior of structures, the intuitive understanding how structure behaves. And
Yeah.
as much digital we go in everything we do, more important will be our understanding of the real world and how things
So
actually works. And so
Mhm.
we can use all the tools that we have available. Otherwise, if
Right.
you don't know the basics, I think understanding the basics with all the tools you have today, you can go anywhere. You can
Right.
you can use it for so many things.
That makes sense. So, if I'm hearing you right, what you're saying is these types of kits help us kind of build on our foundational understanding of structure and how structures work. And I thought it was interesting too when you were talking about the springs and some of the components of your design exaggerate things that might be harder for us to see naturally to almost augment our foundational understanding around things like sway.
Like there's a classification of structure, the sway and non-sway structures that we can show really easy with the model because you can see what it happens.
Right. Exactly. And then that leads right into a conversation about a topic that comes up a lot, which is the future of work. And artificial intelligence has been shaking a lot of people, pun a little bit intended there, where like people don't necessarily understand what it's going to mean to their work. It's certainly something that is impacting the field of architecture and how we think about building things. How is AI and some of the technology waves that are coming, how are they impacting the field? And then how does that maybe impact how we think about teaching people some of the foundational stuff that's going to be needed to be an architect in the future?
Yeah, I think these powerful tools for structural analysis, it's phenomenal. We are reaching some informations that can optimize the use of material, which is really important. How much material you use to build a building or anything else, and this is so important now. And with all these tools, we are getting to something that we didn't couldn't do before. But I think in education, we need to think a lot about it. And because, as I said, if with all these powerful tools, we cannot forget about the things that makes things work and this
Mhm.
basic concept.
Yeah.
And I'm really care about that because I see in architecture school, especially, there's a big lack of information about the technical stuff about structures. And
Mhm.
is you can make something realistic images of buildings that you can simulate in a computer. It doesn't mean you understand that thing will work in real life. And
Right.
we need to make sure our future engineers, architects, they have this notion about the basic stuff, the fundamentals,
Mhm.
which is really important. And
Yeah.
you can use the best software in the world to optimize your structure. If you are trying to optimize a bad solution, the result
Right.
will always be bad. So it's this point that I'm trying to point it. And I'm not saying that MOLA will replace any of these tools, but we need to use them together. This is what I'm trying
Right.
to explain. And
Mhm.
we are doing some experiments, really nice experiments with professors in different institutions that we are teaching parametric design, which is totally digital, with physical
Mhm.
model at the same time. So this is another thing
Yeah.
that we are trying to do, and how we can
Mhm.
maximize this understanding of all the digital tools that we have with the
Right.
physical model together. So I think this will be way more powerful to get in the better future, I think.
Yeah, it's interesting when you're talking about it too, because there is this blending of the human with the technical, and it sounds like what you're saying is what's missing is the tools and the toys and the manipulatives that humans can use to develop a feel for this, develop an intuition about this stuff. Because frequently folks are talking about these blended models where there's a human in the loop, but what kind of skills and sort of foundational understandings, even intuitions,
Yep.
physical understanding of things, those are things that it's going to be difficult to get technology up to speed on. But it sounds like what you're describing is a way for humans to kind of build out their foundational understanding that then will be kind of plugged in to these emerging technology sets.
Yes, and during a design process of a building, there's so many qualitative important decisions that are taken on the
Mhm.
early stages of the design, which is going to
Yeah,
reflect the result like directly. And
right.
even if you're using the best technologies today. We need this
Right.
understanding for taking the right decisions in the early stages.
Mhm.
Even if these decisions are qualitative, they will affect the cost, the solution, the use of material, and a lot of other things based on
Yeah.
this intuition, these early decisions, which is really important. Even money,
Yeah.
time, and energy that you can save by
Mhm.
taking the right decision at the beginning based on your
Mhm.
information and with your knowledge on how things really works. And I think this is really
Right.
important. And I don't see this being like taking a look at when you think about education, how people are teaching structural engineering in schools. We are trying to do our part to try to better this situation and to help to have better professionals and more prepared for future challenges.
Yeah. Well, I was thinking about it coming in and, in our K-12 system, even in high school, if you're interested in architecture, there's seldom any kind of structure to the courses you might take. Like to your point, like if you want to come into an architecture program after high school in post-secondary and beyond, what should you have started sooner and how formal is any of that? And it seems like it's mostly managed through stuff outside of the traditional high school curriculum. Maybe it's an after school program or whatever, but how do you see this evolving? Because it seems like architecture as a field might be similar to others in that there will be a need for architects and structural engineers in the future, but a lot of it is more like an awareness and a pathway problem where the sooner we can get younger folks aware that there's stuff further down the road that could actually be a calling, a career, a profession. How do you think about that? How do you think about, maybe how we break through to
Okay.
start to formalize some of these pathways?
Yeah, especially in structural engineering as a really abstract subject, it's really hard
Yeah.
to show young people that this is really an amazing profession and how
Yeah.
interesting it is to build stuff that will last for years and will be part
Right.
of our cities and all this stuff. And it's really hard to show them how interesting this could be, a really amazing profession. And I would like to
Yeah.
highlight a really amazing work that the CIAOC is the Structural Engineer Association of Northern California. They are
Okay.
doing amazing work using MOLA with high school students. So they do a lot of workshops using the physical model and they do a lot of activity with students relating to their reality. So they take, for example, a specific building where the school is based, so students can relate to their reality and show how these buildings behave and how the engineers do the design for making this possible. So they are doing amazing work with these activities. But again, it's something out of the regular class. It's
Yeah.
another moment where students they need to take these activities, extra class, and but I I don't see a specific way of doing it. This so much things to think about education that we are so into the physical thing about structures and stuff. But I believe
Yeah.
this hands-on where students can play with and see that this could be a really nice and interesting profession. It's a good way to start, I think.
Yeah. And it's also very much in line with a lot of the emphasis on STEM that we've talked about, because there is science, technology, engineering, and math all in architecture. Also, if you throw the A in for the arts, there is an artistic aesthetic to what you're doing here, which is also interesting. And, it does remind me of just a wide range of architecture that you see nowadays, where, I have been fortunate enough to go to Barcelona and, be in a city that was really built by a visionary architect in Gaudi's work. But then the flip side is, you look at a typical strip mall and, what you see off the interstates in the US. I mean, I guess technically it's architecture, but it's also kind of a very base, kind of low level to how people are thinking about solving problems. How do you think about that balance where on the one end there's real like visionary human artistry and transformational thinking happening in architecture. And on the other end, there is just mass, like almost like junk architecture being poured into the universe nowadays. How do you navigate that? Do you have any ideas on how we might help
This
educate
is
folks on this?
yes, this is a really tough thing because what the market asks for, like huge necessity of buildings that we are making every day, and
Yeah,
about about having quality, what we are doing or not, it's something really tough, especially when you're talking about different part of the globe. So we have the culture involved, how we
hmm,
relate architecture to our cities and everything. So I think this is a really, really tough subject that it's something that, of course, it's hard to just say what's the right thing to do. And but it always amazes us when we see these type of buildings that you mentioned, like Gaudi, for example. Um,
yeah,
this is a masterpiece of buildings. And it's nice to mention that he used a lot of physical models to get to the shape of their buildings because
yes,
he didn't have the calculations procedure to do it at the time. So he used
right,
physical models to find the best shape for the building. So
yeah,
it's also a really amazing way of building things. And
hmm,
I think it's again how we use the technology today to design buildings. And
yeah,
are we gonna use what we get from the softwares, or we are actually doing our work as an architect, as an engineer, to set the right
right,
thing to do and not what we are receiving as a result from a calculation machine? And I
really,
think there's so many things involved, which is more
right,
human than just the technical stuff. And maybe we
exactly,
need to take care more about what this related to us as human beings and how the city we work and the environment and everything. So
yeah,
this is a really important thing. It's always a mix. We need to have
mhm,
balance all the time, I think.
of course, yeah, and even literally you need balance, right, to keep the
Yes,
structures up there.
exactly. Yeah.
But also, it does seem like maybe there is a like a communication, education, awareness problem where like more folks should understand the work that Gaudi has done. When I think structural engineering, the other name I think about is Buckminster Fuller and the geodesic domes, where like there is also a long history of almost like first principles thinking in architecture, where like there's only so many ways structures can actually be built. And I do feel like when I talk to architects, to your point, baked into how they operate, it's baked into their intuitions. But what I found interesting about the work you're doing with Mola is trying to think about how can that sort of intuition be taught and how much of that can be learned through physical experience and play. And perhaps that's a place where you could provide some lessons learned or some thoughts about teaching architecture, because I think in some ways you're kind of further along in the thinking because this is a longer standing challenge in the world of architecture. But I think similar conversations are emerging around artificial intelligence and the future of engineering and the future of a lot of other things. How do you teach things that ultimately become intuitive?
Oh, okay. One thing that we like to use as we use a physical model, and which is like it's versatile. You can simulate a lot of it. It's like a Lego set. I like to mention Lego
Yep.
because everyone knows, so it's easy to make this relation. So one thing that we would like to do when we are talking to students is that taking the existing buildings and to simulate that with the model. So this is a really
Mm,
powerful way of showing people why those buildings were designed that way, and
yeah.
so they can understand how this works. And then they start to understand how to read the building. So when you look to a bridge, you can already read how the loads are going there and what's happening inside those columns and cables and stuff. we try to teach this through the physical models because I believe this is a really powerful tool when you build
Mhm.
something with your hands and you have this sensorial experience. It's way better to our brain to understand those
Yeah.
principles. And we believe in this type of approach. Of course, again, not
Mhm.
replacing
Mhm.
anything
Mhm.
there's out there, but mixing and adding to the curriculum, to the methodology that we already have, how we can
Yeah.
add those tools during this process to make it more
Right.
powerful and get a better understand. I think not about the teaching process, but the learning process. We need to
Right.
focus, I think, and how people learn things. And we are trying to help in our way, give our contribution.
Yeah. Well, it's very much hands-on to, like you're physically touching things, which, as simple as that sounds, that is something that kind of goes away after, my son's in first grade now. Like the days are winding down for the physical manipulation of things. And I think that's a real loss, in a lot of ways where, that is very much foundational to how humans have existed for thousands of years, and to think it can all be abstracted, and now also in addition to becoming more abstract and perhaps technical mathematical, there's also the risk of being more technology powered to the point that humans don't really understand how to talk about these things, build out these things without the aid of technology.
Yeah, one thing that sometimes we listen through students when we are in universities for some doing some activities, and sometimes students they're like in the final stage of the course, ready to get graduation, and they know a lot of calculations and all the stuff they do. And when they build something and apply the load and see some deformations in the structure, and
Yeah.
some comments are like, "Oh, so that's the thing that we are studying, and this is how it looks." And it's really nice to have this discovery experience
Hmm.
when you see things, because when you're
Right.
doing calculations and seeing the numbers, okay, you know the result, you know the difference, but when you see things, it's totally different. And
Right.
with MOLA, we apply the loads to the structure with your hands. So you can
Mm.
feel which structure is more rigid than the other one. So you have this
Right.
feeling. It's impossible to have through a digital tool. So
Right.
using
Right.
your hands. So we have more information from the model.
Right, right. And also remembering that things, you mentioned it before, that things are always in movement. There's movement to everything, to even these large, what look like very fixed steel structures. There's still movement and
Movements,
stuff that
deformations,
you'll
and
yeah, yeah, and you'll only understand that, I think, through a hands-on kind of intuitive sense that really can then supplement your more technical sense and the stuff that maybe the AIs can power. I'm talking with Marcio Sequeira, who is the founder and CEO of MOLA, a really interesting structural learning product. And the target audience here is
we are talking about university students, engineering and
okay.
architecture students, and also
Yep.
professionals, because there's some engineering offices and architecture firms using the model as a design tool as well. So it's a big range of age range
Got it.
and professionals.
And you mentioned maybe 14 and up, though, right? So this is not really
Yes.
like an early childhood. That's where Legos and model
Yeah.
kits, and you'll get so far with that. And then if you're to build this into a K-12 curriculum, it would start around the teen
14.
years. And then these tools and awarenesses are still relevant really throughout a career, connecting into architecture and structural thinking, all the things we've been talking about so far.
Yes, exactly. This is mainly because of the type of components that we use in our products. We use really
Hmm.
strong magnets, so this is also something that set this age range. And
Yep.
with our product, that we are really concerned about this as well, about safety.
Hmm.
And
Yep.
one thing that you mentioned about movements and stuff, one interesting thing is that, for example, MIT is using MOLA for since 2018, and they are using specifically on the structural dynamics class.
Mm.
So they are putting MOLA structures on shake tables to teach how dynamics behave and in a building.
Right.
And so because it's visual, you can teach a lot of concepts. like in a way easier
Yeah.
way to explain that. So this is a really
Mm.
interesting subject and area to use the model to
Yeah.
do dynamics.
I immediately went to the earthquake simulator and a version of Jenga where
Exactly.
you're building something a few stories high and then put it on the shake table, see what happens,
Yes,
you
this is
know?
exactly the project they run there. And the students, they need to predict the behavior through calculations.
Uh-huh.
After that, they put the structure on the shake table, they do the experimental analysis, and they measure
Yeah.
everything. And at the end, they need to match the results to see if the calculations it's right and the refined calculations.
Yeah.
It's a back and forth activity, which is
Mhm.
really
Mhm.
amazing. And having the
Yeah.
physical model, it's way better. And one thing
Yeah.
I like to mention, which is about education in general, it's this
Yeah.
professor that is using MOLA on the dynamic course at MIT. She said not about the subject, but the relationship between her and the students were really cold at the beginning of the
Mm.
class because it's a subject
Mhm.
that was really hard to teach and really abstract. As she mentioned, as soon as she put the MOLA kids in the class, the
Yeah.
atmosphere changed. Students were more interested. They were asking questions. They were more close to the professor to talk about. So not just it's easier to teach a subject, a specific concept, but also how
Yeah.
this changed the relationship between professor and students, and which I think it's
Yeah.
fundamental for a good education and a good learning process.
I really like that. It does almost remind you of the physical, intimate, proximal relationships that we have in classrooms, in learning environments, and how certain tools and certain ways of working can actually kind of wake us up out of either being too in our heads, too in our books, too in our tech, and you're suddenly back physically in the same place with others. And that's really a community where learning can happen. It does bring me to a question maybe about designing schools. And that is something that I have talked to folks about. I imagine, as you start thinking about, whether it's in higher ed or elsewhere, how do you build labs? How do you build classrooms of the future? Any perspective there? Any opportunities to maybe learn from MOLA style tools when you're thinking about
Well,
designing learning environments?
yeah, one thing that it's clear for us is that when we are trying to apply MOLA to certain courses and classes, depending the physical structure of the class, sometimes not
Mm.
possible to use MOLA because there's, for example, not big tables. So there's really small tables that you cannot build anything on top of it. So
Yeah.
we need to go to the lab. So I don't know, maybe it's some versatile environments and classes. I don't
Yes.
know. I don't have an answer for that, but this
Yeah.
is one issue that we face when we are trying to use a different material. There's not used usually in a specific class, and how we can
Yeah.
adapt. So sometimes we cannot do the activity because there's not
Right.
physical space thought to that activity. It's so complex subject that
Well, you're almost suggesting a more modular lab-like setup with a lot of like surface area to kind of
yes, yeah,
be a little more hands-on and even collaborative, right? Is
yeah.
the other
And maybe
element
together
where
with computers, I don't know. There's
yeah,
so many
and
things
then
to
put on your VR headset, Marcio, and
yes,
you're all set,
and
you know?
use yes, maybe, I don't
Yeah.
know. It's a
That's part of why I like architecture, I think does activate a different mode of imagination perhaps than other fields because it's building. And then it's also interesting, and maybe you could help us understand if there's anything new and emerging in the field of architecture that you think is relevant. Are there trends out there? Are there new ways of working, new ways of building things, new ways of thinking about design that folks who maybe aren't as deep in the field may not be as
uh,
aware of? What's new and emerging that is kind of capturing your imagination?
I can talk more about Brazil activity because
Sure.
we're based here, more about the architecture of field. I think all the beam models, which are the virtual model of a building on the daily activity of the architects. I think this is
Mhm.
changing now in Brazil, and of course, other countries, this is way more developed. But I
Mhm.
think this is a huge step to more efficiency about buildings, about constructions, about the use of material, and about waste, when you have more
Mhm.
control about what you're building. And
Mhm.
I think this is a really important step to take. But this is not something on top of the new technologies that we have. There's something like more basic, but I think which
Yeah.
is really important for all the our desire to use better the ways, the resources that we have to build.
Mhm.
So I think this
Right.
is really important. Maybe we are going back to the basics as well and how we
It
can.
does sound
Uh,
like a lot of first principles thinking, and then if I'm hearing you right, there might be more awareness of environmental issues and of some of the challenges to architecture that are being powered by things like climate change and, amount of rainfall and the different types of, wildfires are another risk depending on which part of the world you're building in.
yeah,
Earthquakes, another
yeah,
one, but it does feel like there is another element of architecture where it is being built in the actual world that we're living in, so it's probably a little more grounded in some of the emerging challenges around
yes,
climate
exactly. Yeah,
and even like refugee crises too, like the fact that our
yes,
populations tend to be moving a lot more. How do you think about supporting, refugees? And like, there's certainly issues that we're challenged with today in the US. We're getting close to time. I'm talking
uh,
to Marcio Sequeira from MOLA, who's doing really interesting work around structural engineering. Any advice for folks out there who are listening based on your experience? It does sound like, you've been able to blend your love of architecture and the work you're doing there with your love of education and some ability to kind of transform how we think about education. Any advice for folks out there if they're thinking about a career in education, a career in architecture?
uh,
Thoughts?
I think one thing that not really related to architecture, but thinking about new technologies, let's say, just for us not to think about digital all the time. Because
Mhm.
every time we say, oh, we're going to make something new technology, it doesn't mean it needs to be an app or a software or
Mhm.
something AI. We are
Mhm.
using springs, spheres, and magnets. And
Yeah.
this is technology. And we didn't invent anything. We are just using things
Yeah.
that are out there. We are putting together and using another way. So I think there's
Yeah.
so many things we can improve with something simple stuff. Maybe we can improve a lot of things without going too far in digital world, I think.
Yeah. Good advice from Marcio Sequeira, who is the founder and CEO of MOLA. The website is molamodel.com. It's been a wonderful conversation today. We're wrapping up here. I think you gave us some good advice on your last answer, but any concluding thoughts, any, takeaways for listeners who've stuck with us so far?
One thing that I didn't mention is that our company just turned 10 years uh, of
Mm,
operation, but it took me 10 years before that to fund the first kit, the first
mm,
product.
mm,
So
mhm.
sometimes it looks really hard that things are not going to happen. But I kept going because I always believe this mission about education, which I think it's
Mm,
important. And
mm,
it ended up being an amazing journey. And
mm.
so I've now dedicated the last 20 years to MOLA structural system. And usually people don't
Yeah.
know that because they know the company from the day we started. But there was 10 years
Right.
before working with the solution for launching this product.
Yeah.
So I think this is a good thing to mention that especially for
Mm,
students, for people that's going to start now their profession and they are always
yeah.
trying to get to the best job as possible. And most of the time it's not how it works. And they need to
Yeah.
do their path and then go step by step sometimes. And
Yeah.
it took a lot of work to be here. And if we are talking
Mhm.
today, it's because there's so many years of dedication and
Mm.
we need to go for it.
Yeah, it does remind me, interestingly, this came up in another conversation with Brendan Bastide, who was on the show. He was talking about the need for cathedral building in education. I brought up Gaudi on that conversation too, but it does seem like to build a cathedral does take a level of vision and a sort of sense of time that may span something like 20 years or may be a life's work. And you're an example of that and you're kind of speaking to that here. And perhaps that is a place for us to draw some lessons and to think about, to really affect change. You got to have that dedication, commitment to a vision, and then continue to plug away and see it evolve over time. It's been an amazing conversation. Thank you so much for joining me on today's show, Marcio.
Yes, thank you very much for having me. It was a pleasure. And I hope people can enjoy a little bit of MOLA and understand more about structures. Thank you.
Fantastic stuff. We'll include links to Mola and the work that Marcio and team are doing in the show notes for the episode. If you like what you heard, please subscribe, tell your friends, do all the good things. We'll be back again soon. This is Trending in Education.